The first problem is two coaxial cables one and two are filled with different dielectric constants. Epsilon R1 and epsilon R2 respectively. The ratio of wavelengths in the two cables is lambda 1 by lambda 2 is equal to how much? Option A, square root of epsilon R1 by epsilon R2. Option B, square root of epsilon R2 by epsilon R1. Option C, epsilon R1 by epsilon R2. Option D, epsilon R2 by epsilon R1. The solution to this problem is, they are asking ratio of wavelengths. We know that lambda is equal to C by F, where F is frequency of operation, C is free space velocity. But here it is given to different dielectric mediums. So here it is not C, here it is some C dash, which is C by square root of mu naught mu r epsilon r, where mu r and epsilon r some relative permeability and relative permittivity values of the medias. So this wavelength lambda, here it is given epsilon r1 and epsilon r2 only. Mu r is not given. So mu r we are assuming it as 1 if it is not mentioned. So lambda is inversely proportional to square root of epsilon r, which is nothing but lambda 1 by lambda 2 is nothing but square root of epsilon r2 by epsilon r1. So option B is correct one for this problem. Next problem is problem 2. The unit of del cross H is option A ampere, option B ampere per meter, option C ampere per meter square, option D ampere meter. This is very simple. We know that del cross H is equal to J in free space, or J plus 2D by dt, where J is displacement, J is current density, dou d by dt is nothing but displacement current density. So current density, this is the current density. So what is the unit of current density? Current density unit is ampere per meter square. So the unit of del cross H is also equal to ampere per meter square. So option C is correct. Next problem is problem number 3. A uniform plane wave traveling in air is incident on the plane boundary between air and another dielectric medium. With epsilon r is equal to 4. The reflection coefficient for the normal incidence is the reflection coefficient for the normal incidence is option A 0, option B 0.5 at 180 degrees, option C 0.33 at an angle 0 degrees, option D 0.33 at an angle 180 degrees. The solution to this problem is, so here two medias, one is air, another one is dielectric with epsilon r is equal to 4. Normal incidence. What is the reflection coefficient they are asking? We know that the reflection coefficient tau is equal to ER by A is equal to eta 2 minus eta 1 by eta 2 plus eta 1. This is where eta 1 is the medium 1, eta 2 is intrinsic impedance in medium 2. Since eta 1 is air, eta 1 is equal to, since medium 1 is air, eta 1 is equal to free space impedance 120 pi, eta 2 is 120 pi divided by square root of epsilon r, that is square root of 4, 2, that is 60 pi. Then what happens tau? Tau is equal to 60 pi minus 120 pi by 60 pi plus 120 pi. This is nothing but minus 1 by 3. Minus 1 by 3 tau value. So what is the magnitude? If you convert into magnitude, 1 by 3 magnitude, and phase angle is exactly opposite to, that is ER by EI. So reflected is minus of EI. So at an angle exactly 180 degrees phase. 180 degrees phase. So 1 by 3 at an angle 180 degrees. So 0.33, that is equal to 0.33 180 degrees. So this 180 degree phase shift is because ER is exactly opposite to EI. Exactly opposite to ER. ER is equal to minus EI. This is some magnitude. So this 180 degree represents that negative sign. So option D is correct. Next problem is problem number 4. A plane EM wave propagating in free space is incident normally on a large slab. Is incident normally on a large slab of lossless non-magnetic dielectric material with epsilon greater than epsilon naught. Maximum and minimum maximum and minimum are observed when the electric field is measured in front of the slab. The maximum electric field is five times the minimum field. The intrinsic impedance of the medium is option A 120 pi ohms, option B 60 pi ohms, option C 600 pi ohms, option D 24 pi ohms. This problem is a different kind of problem where we have to apply the concept carefully. If you see the solution to this problem, so here first of all, what is the given things? A plane EMF propagating in free space is incident normally on a large slab of lossless non-magnetic dielectric material. So here this is free space, medium 1 is free space, this is a lossless dielectric. It is characterized by epsilon greater than epsilon naught. It is given epsilon value is greater than epsilon naught, that is it has some epsilon r value obviously. Then maximum and minimum are observed and the electric field is measured in front of the slab. This is slab. The maximum electric field is 5 times the minimum field. We know that what is the ratio VSWR or standing wave ratio is ratio of E maximum to E minimum. We know that this one. Here it is given E maximum is equal to the maximum electric field is 5 times the minimum field. 5 times E minimum implies what? VSWR is equal to 5. VSWR is equal to 5. How I can relate? Here it is given the intrinsic impedance of the medium. We have to calculate the intrinsic impedance of the medium. That is the intrinsic impedance of the dielectric medium we have to calculate. For this what we are doing? How we can relate VSWR and reflection coefficient? This is nothing but 1 plus mod tau by 1 minus mod tau is equal to 5. That implies 1 plus mod tau is equal to 5 minus 5 mod tau. That implies 6 mod tau is equal to 4. Mod tau is equal to 2 by 3. So tau is equal to plus or minus 2 by 3. Tau is equal to plus or minus 2 by 3. What is tau? Tau is nothing but reflection coefficient. How I can relate reflection coefficient? Eta 2 minus eta 1 by eta 2 plus eta 1. Eta 2 minus eta 1 by eta 2 plus eta 1. So where eta 2 is intrinsic impedance medium 2, eta 1 is intrinsic impedance medium 1. So this is equal to plus or minus 2 by 3. So here the confusion is whether it is plus 2 by 3 or minus 2 by 3. Suppose eta 2 is greater than eta 1, then obviously it is a plus value. Suppose if eta 2 less than eta 1, then obviously it is minus 2 by 3. So but we don't know here eta 2 is either greater than eta 1 or eta 2 is less than eta 1. How we can know this is based on the given characterization. Here epsilon greater than epsilon naught. Epsilon value greater than epsilon naught. So that means what? If you calculate eta 2 by using the normal formula, eta 2 is equal to square root of mu 2 that is mu naught mu 2. Mu 2 is 1 by epsilon naught epsilon 2. Generally mu by epsilon. So this is here, this value is, that means mu naught mu 2 is 1 by epsilon naught epsilon 2. Epsilon naught epsilon 2. Epsilon 2 value we don't know, but the value is the total value of this is epsilon. The total value is greater than epsilon naught. So obviously what happens? Eta 2, when you are comparing with only mu naught by epsilon naught, the value is less than eta 1. The value is less than eta 1. Since epsilon is greater than epsilon naught, eta 2 is less than eta 1. So with this, we have to consider the reflection coefficient as minus 2 by 3. We have to consider it as minus 2 by 3. So minus 2 by 3 means eta 2 minus eta 1 by eta 2 plus eta 1 is equal to minus 2 by 3. Now simplify this. If you simplify this as 3 eta 2 minus 3 eta 1 is equal to minus 2 eta 2 minus 2 eta 1 implies 5 eta 2 is equal to eta 1 implies eta 2 is equal to eta 1 by 5. Eta 1 is nothing but free space, 120 pi by 5. 120 by 5. How much? 5 2s, 5 4s, 24 pi. 24 pi. 24 pi. So the option is D. Option D is correct. Suppose if you here you consider plus 2 by 3, we will get 600 pi as the option, because it is multiplied with 120 pi into 5 you will get. So 600 pi ohm. So you must be very careful when you are solving this type of problems. So how we can know this, whether it is a plus or minus 2 by 3, is based on the given characterization of the dielectric medium. Here it is given epsilon value is greater than epsilon naught value. Then if you substitute in the denominator part, that means definitely it is the value is eta 2 is less than eta 1, where eta 1 is a intrinsic impedance of free space. So we have to consider the reflection coefficient as negative. So we will get 24 pi as the answer. This is very, very important. Next problem is, it's a very simple problem. The wavelength of a wave with propagation constant gamma is equal to 0.1 pi plus j 0.2 pi meter inverse is option A 20 meters, option B 10 meters, option C 20 centimeters, option D 30, option D is 10 centimeters. Very simple. The solution to this is gamma is equal to alpha plus j beta. Propagation constant is alpha plus j beta. Then they are asking wavelength. We know that beta is equal to 2 pi by lambda. They are asking nothing but lambda. 2 pi by beta, that is nothing but 2 pi by beta. Beta is 0.2 pi, because alpha plus j beta. Beta is 0.2 pi. So pi cancel out. 20 by 2, 10 meters, because the gamma is given per meter. So lambda is also equal to 10 meters. So option B is correct. B is correct. The next problem is, problem 6. A material is described by following parameters. F is equal to 100 gigahertz, sigma is equal to 10 power 6 mho per meter, mu is equal to mu naught, epsilon is equal to 10 epsilon naught. Epsilon naught value is 10 power minus 9 by 36 pi farad per meter. The material at this frequency is option A, good conductor, option B, good dielectric, option C, a good magnetic material, option D, neither good conductor nor good dielectric. The solution to this problem is very simple. Just calculate the ratio of sigma by omega epsilon. Sigma by omega epsilon value calculate. If this value is very greater than 1, then it is a good conductor. Good conductor. If sigma by omega epsilon is very less than 1, good dielectric. Good dielectric. So calculate this ratio and verify whether it is greater than very greater than 1 or less than 1. So for this problem, if you calculate, it is very greater than 1. So the answer is option A is correct. Good conductor.